the cotangent curve. Y equals cotangent of theta, or we could say x. So cotangent, remember, is the reciprocal function of tangent. So on the left here, we have the tangent curve, and don't forget we do technically have some asymptotes in here. Those are kind of your do not cross lines, and that's where we have undefined for our function. So for tangent, we know we have the basic points. We start at the origin. We have asymptotes, so that we have a full period of pi, right? To the left of that origin point is half of the period. To the right is the other half. So we have undefined at negative pi over 2 and at positive pi over 2. We also have points halfway between the origin and the asymptotes. On the left down at negative 1 and the right up at positive 1. And we notice that tangent is always increasing. It's always going up from left to right. So when we go to take the cotangent, remember it is the reciprocal. So all we have to do is take the reciprocal of each of those values. So really undefined would have meant that we had 1 over 0. So when I flip that over, I'm going to get 0 for cotangent. When I flip over negative 1, I still get negative 1. When I flip over 0, I get undefined 1, 0, negative 1, undefined. And it continues that pattern over and over again. And we see that this still has a period of pi. Nothing's really changing there. But anything that was a intercept is now going to be an asymptote. So I usually had an intercept at the origin. Now I have an asymptote there. I would have had an intercept again at pi, so now I'm going to have an asymptote. Oops, an asymptote there. Okay. Anything that was an asymptote is now an intercept. And then my regular points are staying pretty much the same. So I would have had negative 1 and 1, but now instead of them being on the same curve, they're on separate curves. So I see that it looks like tangent has really just been shifted over and reversed, right? So instead now we're always going to be decreasing. So tangent is always increasing and cotangent is always decreasing. All right, so just like with the other reciprocal functions, it is very useful to first figure out where is tangent and then we can work it from there. But we don't necessarily have to. It does work very similarly. So if you know the basic cotangent function, it actually may be easier to just memorize it. So it's up to you. You could either think of tangent first, or you could just kind of memorize what cotangent looks like. If we just memorize what cotangent looks like, we have an asymptote at 0 and an asymptote at pi. Halfway between, we have a point. So that's really kind of what we need to remember here. So again, we have an asymptote at 0 and an asymptote at pi. And halfway between, I'm going to have a point. Just remember with cotangent, we're always falling. Here the a is changing, so instead of 1 and negative 1, it's going to be 2 and negative 2. And again, this might be just as easy to just memorize what this looks like and treat it similar to tangent. All right, so my period is changing in this one. I have cotangent of really 1/2 x, and that means that my b is 1/2. Again, the period's the same, so period is pi over b, or pi over 1/2, which when we keep change flip is going to give us 2 pi. That means instead of my asymptote being at 0 and pi, my asymptote will be at 0, and I think it's going to get cut off just a bit, but 2 pi. Let's see. That would be right here. We're just kind of cut off. Halfway between would be our asymptote. And then again, we don't have an a change, so we're at 1 and negative 1. On the left, this time it's up. On the right, it's down. For c, we have a number on the inside that is our c, and it is going to change our left to right. So in this case, because it's a plus sign, that means we are moving left 3 pi over 4. So my asymptote that should have been at the origin is now going to be at 3 pi over 4. These are counting by over 4, so we have negative pi over 4 here, negative 3 pi over 4 here. So that asymptote is now going to be at negative 3 pi over 4. The one that should have been at pi is going to be over at 1, 2, 3. And if we notice, we still have a period of pi, which is exactly what we're looking for. Halfway between should be a point, and then halfway between we have 1 and negative 1. And last but not least, this 1 is my d, and it's going up 1 space. So we would have still had our asymptotes in the same place, 0 and pi. The point that should have been at on the axis is going to be up 1. The point that should have been at 1 is at 2, and the one that should have been at -1 is at 0. Oops, that's not exactly the best curve. Better. So it's very similar to tangent. If you can remember what this looks like, it's going to be a lot easier. You don't have to transform it quite the same way. That what I mean is you don't have to rely on its reciprocal if you just remember what this one looks like. Cotangent